So now let's take a look at a new trend which we're seeing, which is big data. What happens if you have a big block of data that's a little too big to crunch in any one place? This is a problem that we're starting to see more and more with lots of large applications, particularly some of the large OTT service providers out there. Well, how do you eat a big elephant? The best way to do it is you divide it up into little chunks and eat it one piece at a time. And this is really what big data is all about. In fact, one of the middleware layers that actually helps you manage big data, Hadoop, actually has an icon of an elephant. That's the metaphor that they're using. So if you look at what something like this really does, is you take this large data and you do what's called sharding the data. You basically start to break up the data into multiple little chunks. Once you have lots of chunks in this data that you need to start processing, you add a job control layer that basically says, we have this large amount of data. How do we start distributing this out to lots of resources underneath? And you have both processing resources and you also have data stores underneath. So what you'll find is the data gets distributed to various data stores, and likewise you can start to create processing engines. And this creates a much larger system that allows you to crunch a large amount of data in a very small amount of time. Now the next question is, how does this start fitting in with SDN? Well, there's a couple components. As you get to very large control schemes, you may actually have a tremendous amount of data that you're trying to crunch in a very small amount of time. Sharding the data is a very efficient way to do this. So for instance, if you have a very large network topology and you're trying to do a recalculation in a very small amount of time, sharding out this data is a very efficient way to, for instance, recalculate a large network in less than a couple seconds. And we've already seen some providers starting to look at this way of solving the problem. The other thing that SDN is also going to deal with is now, when you see that you've broken up the data and the processing separate, the actual path between the processing engine and the data starts to matter because you're going to have a lot of communication back and forth. So actually understanding what the topology underneath looks like so that you can optimize processing and put it much closer to your data so that you can have lower latency access and higher throughput starts to become a serious consideration. So now adding this concept of locality of both processing and data becomes a very important input and factor that SDN is actually trying to manage.